Assalamu alaikum wa rahmatullah. Today I am going to speak about the OSI model. The OSI model stands for Open System Interconnection. It is a set of rules and standards for devices to universally communicate with each other. It is made of 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Each layer of these layers have its own functions, and today I am going to scratch the surface of each layer of them. Let's start with the upper layer. The application layer determines the right protocol for the action that the user is taking. I mean, it is the layer that is responsible for the understanding the user's specific request. Whether that's browsing a website, or sending an email, or transferring a file, each action has its own protocol. For example, if you open your browser and type in google.com, then you are running HTTPS protocol. If you send an email, this action uses SMTP protocol, and file transfer uses FTP protocol. Now let's move to the next layer, the presentation layer. This layer has 3 main functions: data translation, data compression, and data encryption. Data translation is translating the data from human language to machine language, zeros and ones, to make it understandable for the machine. After the data translation, it starts to make data compression to make it easier and faster to send it over the internet. And the last function of this layer is data encryption. The third layer is session layer. It has 4 main functions: transmission mode, authentication, authorization, and session management. Let's begin with the transmission mode. It generally divided into 3 types: simplex, duplex, and full duplex. Simplex is one-way transmission. One sender and one or multiple receivers, but only the sender can send data and the receivers can't send back any data. In duplex mode, receiver and sender can send and receive data, but not at the same time. And the last transmission mode is the full duplex. In this type, receiver and sender can share data at the same time. Authentication is basically about verifying who you are. It is like when you try to log into a website and you use a username and password. That process checks to make sure that you are who you are claimed to be. Authorization, on the other hand, is what you are allowed to do after you have been authenticated. So once that system knows you are, it decides what permission you have. The session layer establishes, manages, and terminates connections between applications. It controls the dialogue and inserts checkpoints into the data stream for synchronization. These checkpoints allow reliability by enabling a connection to resume from a failure point without starting over from the beginning. The transport layer is the 4th layer. This layer is responsible for data flow, data segmentation, and determining the appropriate protocol needed for transfer, UDP or TCP. Flow control is a networking mechanism that manages the rate of data transmission between a sender and a receiver to prevent the sender from overwhelming the receiver. For instance, if a PC capable of sending data at 100 megabits per second transmits to a mobile phone that can only receive at 15 megabits per second, the mismatch in speed would result in data loss. To prevent this, the receiving device sends feedback signals to the transmitter, instructing it to reduce the transmission speed. Function number 2 of this layer is data segmentation. It divides the data to smaller segments. Each segment has a sequence number so the receiving system can put them back in the correct order, and a port number to direct the data to the correct application or service running on the destination device. The final function of the transport layer is to determine the transfer protocol, either TCP or UDP. TCP is reliable but slower, while UDP is fast but unreliable. The network layer has 2 functions. Number 1, logical addressing. 2, routing. Every device in a network must have a unique identifier to be reached, similar to how a letter needs a physical address to be delivered. The network layer assigns a unique IP address to every device. When data is sent, this layer identifies both the source and the destination using these IP addresses. One of the most critical functions of this layer is routing, which is the process of selecting the best possible path for a packet to travel from the sender to the receiver. To determine this path, the network layer uses specific protocols such as RIP, Routing Information Protocol, OSPF, Open Shortest Path First. While the network layer uses logical IP addresses, The data link layer uses MAC addresses. A MAC address is a unique 48-bit physical address assigned to a device's network card by its manufacturer. It consists of 12 hexadecimal digits. The data link layer receives packets from the network layer and adds a header and a trailer to them. This header and trailer contain the source and destination MAC. The physical layer is the lowest OSI layer responsible for transmitting raw data bits through physical network hardware. Handles physical and electrical data transmission, includes cables, connectors, plugs, and receivers, transfers raw bits between devices, defines hardware standards and signal types. Functions of physical layer. The physical layer is responsible for sending raw data as bits over a physical medium. It converts data into signals that can travel through wires, fiber optics, or wireless channels, encoding, and turns these signals back into data at the receiver, decoding. It ensures signals are transmitted correctly and uses techniques like modulation to prepare the data for transmission and demodulation to retrieve it at the other end. This layer also decides how data flows one-way, two-way, alternately, or simultaneously through transmission modes and controls the speed and timing of data transmission to keep everything running smoothly.